The last class we completed about the Rydberg constant, and we done a few examples also. Next, one question for number of spectral lines. The question is, in a hydrogen spectrum, in a hydrogen spectrum, if electron moves from, from 7 to 1 orbit, 7 to 1 orbit by transition in multi-steps, by transition in multi-steps, then find out the total number of lines in the spectrum. Find out the total number of lines in the spectrum. Total number of lines in the spectrum. So there we have to find the total number of lines, so that we know the formula. Total number of lines equal to total number of lines equal to n2 minus n1 into n2 minus n1 plus 1 by 2. This is the formula. There n2 equal to 7, the 7th orbit, and n1 equal to 1. So substitute these values here. n2 7 minus 6 into we'll get 6 plus 1 by 2. After simplification, we'll get the answer 42 by 2. So there how many lines? 21 spectral lines are possible. Total 21 spectral lines. From this one, this is direct, we can find the answer from principle, or else we can find like this also. For example, here Lyman series, one more method, Lyman series. In Lyman series, how many spectral lines are possible? Actually, in Lyman series, n2 minus 1. That means there the Lyman series, the maximum 7th orbit, 7 minus 1 will get 6 lines. And Balmer series, n2 minus 1. So there 7 minus 2. Here 5 spectral lines. And then after Fashion series, Fashion also same, n2 minus 1. n2 is a 7 minus 3. So we'll get 4, like bracket. n2 minus 1, that equal to 7 minus 4, will get 3. Okay, sorry here. This is 7 minus 1 number. N1 value 1 here, not 6. Ah. And next to fund series, fee fund, fund series. Fund same N2 minus 1, 7 minus 5. Here we'll get 2. And the final one is Humphrey. Humphrey. N2 minus 1. Here 7 minus 6, 1. The total number of spectral lines are, if you count this total, all will get 21. From this way also we got the total number of, and from this formula also we will get same answer. Both are same only. Okay. I will give one more question for homework. Shall I remove? Shall I? Okay. Next question, homework. Amma. Write this question for homework. In a hydrogen spectrum, if electron moves from, in a hydrogen spectrum, the electron moves from, 6th to 2nd orbit. 6th to 2nd orbit by transition in, multi steps, transition in multi steps. Transition in multi steps. Then find out the number of lines in spectrum. Then find out number of lines in spectrum. Then find out number of lines in spectrum. Yes, 10 answer. Okay. And next, the last question write down here. This is for also homework only. In hydrogen atom, if the electron moves from, from nth orbit to first orbit, nth orbit to first orbit. The electron moves from nth orbit to first orbit by transition in multi steps. By transition in multi steps. Then the total number of lines. Then the total number of lines. Observed in the spectrum are observed in the spectrum of observed in the spectrum of spectrum R 10. Total number of lines will be 10. Then find out the value of n. Then find out the value of n. Okay, here I will give the hint there n. Answer what is that? The n2 minus n1 into n2 minus n1 plus 1 by 2. Okay. Then the total number of spectral lines are 10. 10 equal to n2 minus n1 entama 1 and n2 minus 1 plus 1 by 2. దీన్ని క్యాలిక్యులేట్ చేసి n వాల్యూ చేయండి. ఓకేనా? I'll find out n. Okay, I am removing. This is homework. Shall I remove this? And these applications of bohrs are completed. And now limitations of bohrs model. ఇన్ని రోజులకు అయిపోయింది బోర్స్ మోడల్. నెక్స్ట్ లిమిటేషన్స్ ఆఫ్ బోర్స్ మోడల్. In limitation, the first one, Bohr's theory does not explain the Bohr's theory does not explain the Bohr's theory does not explain the spectrum of multi-electron atoms. Spectrum of multi-electron atoms. Bohr's theory does not explain the spectrum of multi-electron atoms. And one more, why the angular momentum of angular momentum of the revolving electron momentum of the revolving electron is equal to nh by 2 pi is equal to nh by 2 pi has not been explained by Bohr's theory. Next, Bohr's theory does not explain the Bohr's theory does not explain the Bohr's theory does not explain the splitting of spectral lines, splitting of spectral lines, splitting of spectral lines in the presence of magnetic field, in presence of magnetic field. When splitting of spectral lines in the presence of magnetic field, that is called Zeeman effect. That means the Bohr's he could not explain the Zeeman effect. And or electric field also. Or electric field. That is Stark effect. Splitting of spectral lines in the presence of magnetic field is Zeeman effect. And the splitting of spectral lines in the presence of electric field is Stark effect. These both he could not explain. Okay, these are the limitations of Bohr's model. Bohr's theory does not explain the spectrum of multi-electron atoms and why the angular momentum of revolving electron is equal to nh by 2 pi has not been explained by Bohr's magnetic field. The next concept is wave mechanical model of an atom. Wave mechanical model of an atom. Wave mechanical model of an atom. This is heading. Wave mechanical model of an atom. This model consists of following. This model consists of that first one is de Broglie concept. De Broglie. De Broglie concept. And the second one is Heisenberg uncertainty. C. Uncertainty principle. Heisenberg uncertainty principle. De Broglie concept is nothing but dual nature of matter. Dual nature of matter. Okay, wave mechanical model, it consists of two, that is de Broglie concept and that is nothing but dual nature of matter and Heisenberg uncertainty principle. Now keep the heading the first one, then the dual nature of matter, de Broglie concept. The dual nature of matter. So that means here the wave nature of electron. the wave nature of electron. అంటే సింపుల్ ఇక్కడ ఒకటే విషయం చెప్పినమ్మా, ఎలక్ట్రాన్ కి వేవ్ నేచర్ ఉంటుంది, పార్టికల్ నేచర్ ఉంటుంది. దట్స్ వై దట్ ఈస్ డ్యూయల్ నేచర్. వేవ్ నేచర్ యాజ్ వెల్ యాజ్ పార్టికల్ నేచర్. దట్స్ ఇట్. So in 1924, no need to remember this year. In 1924, a French physicist, Louis de Broglie, Louis de Broglie suggested that if the nature of light is both that of a particle and of a wave then this dual behavior also should be true. Also for the matter. Okay, according to this, the first point, I am removing this one. Shall I? Okay. Okay, here also the one more point I will write here. According to de Broglie, the wavelength according to de Broglie, the wavelength, that is nothing but lambda. The wavelength lambda of an electron is inversely proportional to its momentum. That is nothing but P. That means here the lambda is inversely proportional to its momentum. Lambda equal to h by P. Their H we know already, that is Planck's constant. Planck's constant, and P is nothing but momentum of electron. Momentum of electron. Okay, copy this one. Next point I will write here. So according to de Broglie, the wavelength of an electron is inversely proportional to its momentum. Shall I remove this page? Oh, okay. And here the wavelength is inversely proportional to its momentum, right? That means the lambda is 1 by p. That lambda equal to proportionality constant, that is Planck's constant, and p is the momentum. And this we can write as the lambda wavelength equal to h by mv also. Why we can write h by mv? Why? Because momentum p equal to momentum, that p equal to mass into velocity. Mass into velocity v. So lambda equal to h by mv. The above relation can be proved as follows by this completely related to physics. That's why they have given directly. These all derivations completely you will get in physics concept. No problem. Okay. The above relations can be proved as followed by using Einstein equation. Einstein's equation. Planck's quantum theory, Einstein equation, and Planck's quantum theory, and wave theory of light, light. Wave theory of light. What is the Einstein equation? Einstein equation E equal to mc square. Yes, where E is energy, m is mass of body, m is mass of body, and c is its velocity, and c is its velocity. So E equal to h nu. According to Planck's quantum theory, what is that? E equal to, according to Planck's quantum theory, E equal to h nu. That equal to hc by lambda. H into c by lambda. Okay. This is according to Planck's quantum theory. According to Planck's theory. And c equal to nu lambda. This is according to wave theory. According to wave theory. So that's why this is nu equal to c by lambda. ఇక్కడ వచ్చింది అదే అన్నట్టు. Instead of nu, we wrote c by lambda. Okay. And this is just assuming equation number 1. But according to Einstein, okay, Amma, it will end the session less than 1 minute. Okay, complete up to here. We'll discuss tomorrow remaining concept. Write down faster.